Hello, this is our third of 5 videos in chapter 3, section 1, and here we're going to be finding the difference quotient of a function. So let's begin. What is the difference quotient? The difference quotient is a function f at x is given by the f of x plus h minus f of x all over h. Now, this is one of those things that a lot of math teachers kind of struggle with themselves or whether they should put it even in a college algebra course, because it's not technically a part of this class that you really see this a lot. You'll see this difference quotient a lot in Calc 1, and it's got to do with derivatives, but it also has to do with slope too, and because it's kind of the same idea. And the difference quotient is kind of like the slope. And if you want to see how that relates to that, send me an email and I'll show you that relationship and just say, how's the difference quotient and the slope related? And I would be glad to give that out and send out the student request videos. But for us, all we really need to know how to do is how to evaluate using the difference quotient. So yes, this is exactly the same process as you learned back in the previous video, the second video of chapter 3, section 1. So you should have already gone through that video already. So this is nothing more than a continuation of this. So for you guys who are going to continue on into calculus, when you get it in that class, this is not going to be something, a new concept for you. You will have at least seen it before. And that's the purpose we put it into this course for those people. For the rest of you guys, it's just a matter of being able to get that one extra practice of how to evaluate a function. Okay? So let's look at this. So we're going to find the difference quotient of a function using those formulas or those functions. F of x equals 2x squared minus 3x, f of x equals 4x, and f of x equals the square root of x. Okay? Now, each one of these is complicated for a different reason. Okay? The one in the middle, it's complicated because you've got a fraction going on. One on the bottom is because it's got a square root involved. The one on top is complicated because it's got two terms. So every one of them has its own reason for being a little difficult. But at the end of the day, it's just about evaluating the difference quotient. The biggest problem is, what is the difference quotient, and remembering what it is. It's one of those things you need to put on a flashcard and just memorize it, okay? Especially if you're going to use it a lot. For our class, if I want you to evaluate the difference quotient, I will give it to you. I'll give the formula to you on this one, okay? Because it's not really part of this course, as I said. But if I'm going to ask you to do it for this course, then I'm going to give you the formula. And all you got to do is do the same exact thing what we had been doing in the previous sections, although it's a little bit more complicated. Okay, so let's look at one. Okay, let's look at the solution for the first one. So it's f of x plus h minus f of x all over h. And again, I'll give that to you. Now, what is f of x plus h? So you plug x plus h in to the formula. So it's going to be 2 times x plus h squared minus 3 times x plus h. That is f of x plus h. But that's not all. Now you got to subtract the function. So that's where you subtract 2x squared minus 3x, because that's what the function is. Look how long that fraction is on the right. That's all over h. And now here's the process. All you have to do now, and I say this kind of tongue-in-cheek, all you have to do now is simplify that down. Okay? Because simplifying that down gives you a lot of terms, giving you lots of opportunities to make silly mistakes. So that's why you have to be very methodical when your calculations. One little, missed sign is going to mess up everything. Okay? So we got x plus h squared. So we got to FOIL that out. So like I said, if you thought x plus h squared was x squared plus h squared, which is not, then that's the first place you're going to make a mistake right then and there. But x plus h squared is x plus h times x plus h, which turns out to be x squared plus 2x h plus h squared, which is the next step below us. Leave in the 2 there, and then distribute the minus 3. So it's a minus 3x minus 3h. Now distribute the negative, so it's going to be a minus 2x squared and a plus 3x. Why is that plus 3x? Yep, that negative goes through, so it's going to be a plus 3x. All over that lonely h on the bottom. A lot of people are like, how far do I go? When do I know when I'm done? When that h on the bottom is canceled out legally. What I mean by legally is by a step that you can actually do it, not just because you want to get rid of it. So I'm done because I'm done because I got rid of it. Well, if you got rid of it by a wrong technique or a technique that is not allowed, then you're not finished. For example, a lot of people will say, well, I'm looking above and I see that negative 3h, that third to the last term. That third to the last term is a negative 3h. So I'm going to take that negative 3h and I'm going to cancel the h on the bottom and call myself done. That's not legal. That's not, you can't just take that h and cancel with one term in the numerator. So only way you can cancel the h out is if you got h factored out at the front. And that's what we're going to end up having to do, is taking an h out to the front. But before we can do that, we have to combine some terms. So our next step is to distribute the 2. So it's 2x squared plus 4x h plus 2h squared minus 3h minus 2x squared. Now notice what I did. I combined something really quick. There's a minus 3x and a plus 3x and the third step from the bottom. There's a minus 3x plus 3x. They canceled. So they're canceled out. Now, the next step, you're going to see a negative 2x squared and a positive 2x squared at the beginning. Then those go out. So what happens is the terms that don't have an h ends up canceling out or going away. Okay? Look what's left. We have 4xh plus the 2h squared minus 3h. Do you see a common theme between those three terms? They all have an h in them. So I'm going to factor out. So if I factor the h out, then this is where it's legal to cancel, because it's being multiplied, h is being multiplied by something on top. So you can cancel them out. So that's when those are gone, you end up with 4x plus 2h minus 3. You can't simplify any further. There's no more like terms, so that's when you know you're done. Now this is where it's really hard on college algebra students, because to them, 4x plus 2h minus 3 means very little to them, okay? And I see it because I've had calculus. That means something to me because of something called a derivative. And that's going to be your first step into the derivative world. But for a college algebra student, it's beyond the scope of this course, so that's not a value to them. So you're just going to have to some things you just have to fight it and just kind of move on and say, oh yeah, okay, I can do it. And then chances are, if you never see it again, that's fine. But for those who do move on to a higher level mathematics, they will appreciate that, and when they get into that course. But it's called the difference quotient. But it's fine that we can put it in this course simply because what are we doing here? We're evaluating the function at the beginning, and from the rest of the way, from step 2 down, it's all about simplification. From step 2 down, it's all about simplifying, combining like terms, algebra, canceling terms out, algebra, canceling factors from top and the bottom, algebra. So that's why we can do it in this course. That's why we should do it in this course, to give you extra practice. But it kills 2 birds with 1 stone, because it does help those students who are going on to calculus as well. Okay, so, all right, so that's the first one. And as you can tell, it took us about 6 steps to get there. Now you know why people don't like this so much. Okay, the next one is the 4 over x. Okay, we're going to apply the difference quotient to 4 over x. So it's f of x plus h minus f of x all over h. Okay, now f of x plus h is going to be 4 over x plus h, because that's what f of x plus h is, off to the side. In blue, f of x plus h is 4 over x plus h. minus f of x. But what's f of x? Well, that's the 4 over x. So the term of the fraction that's on top, that's got the red x plus h underneath it, is the f of x plus h. And the minus 4x is the f of x. But it's all over h. It's all over h. Now, when you get to that point, again, it's the algebra is really deep right here. You have to put the two fractions together. So, and then you have to that means you got to get common denominators. So the first fraction needs the x. That's why it's 4x. And the second fraction needs the needs the x plus h. So you get the negative 4 times x plus h. But the common denominator is the product of x and x plus h. So that next step down, putting those two fractions together, it's all about finding least common denominators and combining the fractions together. But at the end of the day, look what's on the bottom, over the h. So it's all over the h. And then we got to subtract those. So we get 4x minus 4h minus 4x minus 4x minus 4h. And then x times x plus h times h on the bottom. Now I did a couple of things here. I distributed the negative 4 on top. That's where the negative 4x, negative 4h comes from. But then I also inverted and multiplied the h and made it 1 over h. And that's why the h is snuck down underneath the fraction. So if you multiply by the 1 over h, that's what you get. It's inverted and multiplied. You may have heard that terminology before. Then it becomes the 4x is canceled. Negative 4h over, now notice what you have left, x times x plus h times h. They're all factors on the bottom. And all factors, and there's an h factor on the top as well, so they cancel out. And so we get negative 4 over x times x plus h. Now that negative's off to the side. Probably looks better if you put it back up there to 4. I don't know why I left it, put it out front, but the negative should be at the top, negative 4 over x times x plus h. It's the same either way. It's kind of hard. Sometimes you'll lose them when you put it out in front of the fraction, like I got it there. And I almost lost it just now when I looked at the bar. I was like, where'd my negative go? Oh, it's out front. If I put up with a negative 4, it's easier to see and keep up with. So, but either way, it's negative 4 over x times x plus h. So you're like, how do you know I'm done? Because I canceled the h that was on the bottom by itself. And you're like, well, there's still an x plus h in the problem. Yeah, there will. They will still have an h in them. But the h canceled that you needed to cancel. That's how you know you're done. Okay? And then our third one is f of x equals the square root of x. This is probably the toughest one of them all. And you're like, why is this one tougher than the rest of them? Well, it's because the square root, in the simplification process, you're actually having to introduce something that's not in the problem to begin with. And that's always bad news when that happens. It's a procedure that you do it. It's what we call, it's just a rule of the game it's a game of thing, when you're trying to simplify things down. It's just a trick. It's what we call a math trick. So you learn these tricks. Will you remember all the tricks? No. More you're exposed to them, the better off you'll be. You'll see what I'm saying when we do the problem. All right, so we have f of x plus h minus f of x all over h. So f of x plus h is the square root of x plus h minus the square root of x all over h. Now, if you leave it right there, you can't really combine those two terms. Okay? You cannot combine the square root of x plus h minus the square root of x. There's nothing you can do with that. And it's already under one fraction. So at least the other one, we could put them under the same fraction. There's two different fractions, and we could put them together into one fraction. And when we did that thing, something canceled out. Okay, but this one, we can't put them together in the first place. It's under one fraction. So what do? Well, look at our next step. We multiply the top and the bottom by what we call the conjugate of the numerator. So it's the square root of x plus h plus the square root of x, top and the bottom. That's called rationalizing the numerator. Why is that called rationalizing the numerator? Because right now the numerator's got the square roots in it, and that's irrational. So when we get through multiplying by the conjugate, the numerator will know how long the the radicals involved. Okay? So let's look at that. So when you multiply the square root of x plus h, that's the square root of x plus h. That's the square root of x plus h squared. And then the outer and the inner will cancel. That's why you multiply by the conjugate, so they cancel. And then negative square root of x times the positive square root of x is negative square root of x squared. The denominator has the h down there, so the h is still there, but the square root of x plus h plus the square root of x is down there now. So I moved the radical from the top. You're like, did you? Well, I'm going to. I haven't moved the radical out quite yet, but I'm going to. But now it's in the denominator. So what is the square root of x plus h squared? It's x plus h. And what is the square root of x squared? It's x. And those x's cancel out. So what's left of the numerator is x plus h minus x, which is just the old h up there. So off to the side, that's why I showed you there. The square root of x plus h squared minus the square root of x squared is x plus h minus x. And the x's cancel, leaving me with just the h. So that's how that comes about. So doing that leaves me with h that can now be canceled with the h. Remember I told you, that's when you know you're done, when you can cancel those h's out. If I didn't multiply the top and bottom by the conjugate, I would have never got to the point I could cancel those h's out. It's a math trick. And students don't usually like the math tricks if you're just learning this stuff, because it's like, you're playing a video game. With my kids, they know where certain things at when they're doing video games. I'm like, how are you supposed to know how to do that? You just play it long enough, you learn these tricks. How do you know there's a doorway going in that game? I didn't know that. You can't even tell there's a door there. You just know it's there. Okay? It's the same thing here, but it's just in the math world. Okay? This is one of those doors that can get you through to get to the other side. Okay? So that's the kind of the idea. You just got to be around it enough and be willing to do it enough to figure out those tricks. So anyway, let's move on. So that becomes, the h's cancel, 1 over the square root of x plus h plus the square root of x. And see, for some people, that just doesn't look right. Have we got rid of the h that we said we need to get rid of? Yes, we did. Then that's got to be it. Okay? As ugly as it is, that's what it is. All right? So, again, if you want to know the reason why we really talk about the difference quotients, okay, send me a reply. Send me an email to say, hey, I'm kind of interested in this. I didn't want to waste a lot of people's time who are not going to move on, who are not interested in it. I do need you to know the process of how to do the difference quotient. I don't need you to want to know where this is going to lead us to later on, especially if you plan on never taking calculus in the first place. And but it's pretty nifty thing. So, all right. So that concludes this video. And as always, if you have any questions on it or anything else, you let me know. And you have a good day.